Okay, we are going to talk about conic sections today. My suggestion for you is to take these notes, like write them in your notebook, maybe write this and this. I did post them as pictures in Google Classroom, but those are the 2 pages of notes I would take. So you want to pause it and write that, that'd be fine. Let's close this all out here. Where's my notes at? Okay, so we're going to talk about the parabola. First of all of these are conic sections. There's going to be 4 sections, and we're going to talk about conic sections. And what conic sections they are just what they sound like. They're sections of a cone, and there actually are 2 cones that are stacked on top of each other. So if you have 2 cones that are stacked on top of each other, see, I have some really cool things I can pass around the room if we were in the room, but we're not. Basically, if you have 2 cones that are stacked on top of each other like this, you can take a plane or like a big knife, like a saw type thing, and you could cut it. And there's only 4 different ways you could cut it. And one of the ways would be at a slant. One would be straight across. One would be at a slant that touches both ends of the cone, like this one is going through the top of the cone. And then the other one would be a vertical cut. And each one of these makes a conic section. I have a little video kind of showing that to you here. So like if you cut it straight across, there's your circle. She's slow and she actually talks in a really heavy accent. So I muted her because I thought you guys would be mature. Okay, so if you cut here, it's like an elongated circle, which that is called an ellipse. That is called an ellipse. If you take the top off there, it's like how the planets orbit is an ellipse. If you cut it here on the side, this is a parabola, and you have a definition of a parabola already, and that will still hold true, but we're just going to expand that. So there's the parabola. And if you do it completely vertically, you will actually get 2 pictures, if you will, or figures, but they are related, and those are called hyperbolas, and they kind of look very much like parabolas. I feel like they're a little bit pointier in my opinion, but that's what the conic sections are. Okay, so like I said, parabola is kind of an old idea, but we're going to add 2 new things to the old. So before you knew what an axis of symmetry is, it would go straight through the vertex, and you also knew what the vertex was. And the only thing that you knew before, though, was that a parabola could look this way. The cones actually could be stacked the opposite direction if you wanted to. And because of that, not all of these guys will be functions, especially like obviously a circle is not a function or an ellipse or a hyperbola, but you could turn a parabola on its edge. So that is going to be a new idea. Now, these 2 points, the directrix and the focus, are how these things can be constructed. So the focus is always on the inside of the parabola. I want you to kind of think of an eyeball. If you're in music at all, it kind of reminds me of a fermata, the bird's eye. Focus makes me think of eyeballs, and they need to be on the inside always. The directrix will be on the outside, and they are the exact same distance apart because the definition of a parabola actually comes from, let me see if I can get my pen out here. It comes from this focus in the directrix. If every single point on a parabola, where is my pen? Why is nothing is happening? Like for real. I'm just writing, and nothing is happening, and it says it's on. This is my life. This is my life. It's just not on. Okay, so I'll show you with the mouse. So here, like this dot right here. If I draw a straight edge here and I measured that out, see, when I mark, nothing is, there it goes. And then I made a perpendicular line straight down here. That distance is the same. If I go here the distance from here to here is the same as the distance from here to here if I was to measure it out. So I have another video that can show you this. The video is only 8 seconds. And they drew circles because a circle has the radius is the same. So do you see how that distance to the directrix is the same as this? Okay, so watch. So it's a bigger circle, same. And then the circle gets smaller, but it's always the same. And then here it's itty bitty circle and it gets bigger, but the distance is the same. And that's where it's coming from. Okay, so that's why those 2 points are important. And we are going to be learning lots of formulas, lots and lots of formulas. But here are the ones that I need you to know only today. We're only going to talk about non-translated. Okay, so this focus and directrix are really, really important. And the number that's going to tell us how far apart they are is this P value, okay? So from the vertex to the focus, it's P away, and it's also P away this way. Focus is always in the inside. So if it is a smiling normal x squared parabola, you're going to get the x squared by itself. And then whatever is in front of the y, whatever number is in front of the y is actually going to be 4p. So then what you'll do is you'll do some calculations to figure out what p actually is. And once you can figure out what p is, then you could calculate things out. So I'm trying to unplug my slate to see if I can get this thing working because I don't understand why it won't mark. Let me see if I can pause it here. I don't think I just said this is sad for me. One thing, sorry. I am kind of videoing, but I didn't pause it, so let me do this. Yeah, dogs. Okay, fixed it. Sorry, that was a little bit annoying for you. But sometimes you guys are a little annoying for me. I mean, not lately because I miss you so much, but you get what I'm saying. Okay, so once you figure out the P is, then you can graph it. Now, it could also go this way. It could go to the right. And this time the y is squared because that's not normal. P is still on the inside. Okay, directrix on the outside, but that's P away, right in the middle. And P could also be negative. If it was negative, it would be a frowning parabola, or on the other side of this. Okay, now that's all I need you to write down today. I'm just going to kind of give you an example here. Do not write this down because we are actually going to talk this about tomorrow, but this is just so you can see what we're talking about here. So they're going to give me an equation. Now this looks like normal. Yes, you could totally graph this like we used to. Y equals right in your calculator. But they want us to know what the focus is and directrix, and you cannot do that from your calculator. So what we will do is we're going to get the square term by itself. Okay, and when I get the square term by itself, I'm going to multiply both sides by -12. So I get -12y equals x squared. Now, since the x is squared, I know that it's either going to be smiling or frowning. The number in front of the y, that guy is 4p. So now I have 4p equals -12. And I get that p is going to be -3. Because p is negative, I know that is going to be frowning. So then what you would do from here and these are all non-translated. They're going to be parentheses and stuff next week, which makes things more complicated. But since p is negative and there's no parentheses anywhere, the vertex is at 0, 0. I'm going to count 3 away, and that's my focus because the focus is always inside the parabola. And then I'm going to count 3 the other way, and that will be my directrix. So my directrix is going to be y equals 3. My focus is going to be 0, -3. And then to get the other points, what you would actually do is an XYT table. And you could just plug in numbers that are nice. That's the worst part, is the XYT table. But I think a lot of it will be multiple choice for you. Okay, so it would just be, if I plugged in, I don't want to plug in 1. Let's plug in 6. Because if I plug in 6, 6 squared is 36. 36 divided by -12 is -3. And there's symmetry still. So it would be just a wider parabola. Okay? But we don't have to do that until tomorrow, but that's just a little introduction. And then here's another guy. On this guy, they're just giving you hints. They want you to find the equation. So they say the vertex is 0, 0, and the focus is 5, 0. So once you know that the focus is there, you know that the focus has to be inside. So since the focus has to be inside, the graph has to go this way, and that's going to be a y squared. This also tells you how far apart the focus is from here. Remember, that's P away. So we also know that P is 5. Since P is 5, 4P is 20. Y is squared. It's going to be 4Px, so it'll be y squared equals 20x. And I could even tell you where the directrix was if I want, because that's going to be 5 away in the other direction. That's x equals -5. And this is just a sketch. It's not very good. If I wanted to pick something that would work out pretty nicely, y is squared. If x was 5, guys, 20 times 5 is 100. Y squared is 100. Y could be 10. So it's going to be pretty wide. It's going to be a wide parabola there. Okay? Again, that's just the introduction. I really just needed you to get the notes today, and we'll do about 8 problems tomorrow on my math lab, and that'll be it.